Good evening to everyone. This is Dr. Polaiah, working as a professor in the Department of CSE, Data Science. So I'm very happy to share today video lecture for the discussion of one of the topic from module number 1. So the name of the topic which we are going to see that some basic relationship between pixels. So we are going to study especially the pixels, between pixels. So how the pixel to pixel may going to have certain relationship with understanding. Okay. So we'll see this topic in detail by the help of agenda. So what is the today topic agenda is topic introduction, course outcomes. Anyhow, we are going to see each and every topic because we are studying is outcome based education. So course outcomes mapped with the module 1 of particular topic is necessary here. So what is the topic today we want to discuss is, that is the third objective is here. Third one is third agenda is some basic relationships between pixels. Of course, we are regularly understanding that each and every concept is necessity to understood that with certain application. Here also we are going to understand very perfect for particular this topic applications also. So coming to the mapping is here, that is our topic learning outcome. How we are going to achieve in this sense, the topic which we selected is some basic relationship between pixels. So topic learning outcome may going to see here in terms of gain knowledge regarding the concept of some basic relationship between pixels, especially in digital image processing system. So then once you learn that outcome, then immediately we are going to see the course outcome, which is we are studying image processing and analysis in terms of summarize the complete basic concept is here. Also we are concentrating is relationship between pixels in digital imaging system. So once we understood the agenda is the first topic in the agenda is itself, we had to understood the complete basic relationships of the pixels introductions of that topic. So what is this introduction is here? We know very well that is what we are going to understand is digital image. Okay. So here the digital image is compared with the a normal image, that is image when we can call as a digital image. That is especially we have to understand. So here digital image we can call by converting an image into digital only. So to convert that, to see that conversion, okay, to call an image into a digital image, we have to understand our basic relationships of the between pixels only. Once we understood this basic pixels, then only we can able to convert an image into a digital image. So we can able to see that digital images of information, that means the content of the digital image which we wanted to see step by another is here going to help this topic knowledge only. So what is this topic knowledge is here? The digital image is composed of a finite number of elements, each of which has a particular location and a value. So location and particular location and a value which help us to understand to define a pixel. So that means what we want to understand here is the meaning of finite number of elements of a digital image is here. We are going to define, we are going to be referred that these elements are referred to as fixture elements, image elements, pels and pixels. Okay. So what do you mean to understand here? So that means The elements are referred to as a picture elements, number 1. Number 2, image elements. Number 3, pals. Number 4 is pixels. Okay. So based on here, among these 4, one of the important one which we want to consider as an important image element is pixel only. As is pixel only. So what is this pixel? How can we name that pixel? Pixel is the term most widely used to denote the elements of a digital image. I'll repeat once again. Pixel is the term most widely used to denote the elements of a digital image. So that is important here. Okay. So if we wanted to understand the digital image content, only is possible to understand that in terms of or in the form of or in terms of pixels only. In terms of pixels only. So once you understood that relationships of the pixels, so in a digital image, how can we understand that? How can the pixels can have relationship one to another in a digital image? So let me see that I'm naming here that pixel as a neighbors of a pixel. Meaning of it? Meaning of what does it mean this? The meaning of a pixel relation we can name as neighbors of a pixel. So the neighbors of the pixel here, simply we can say that a pixel we denoted as a P at coordinates x comma y has 4 horizontal and vertical neighbors whose coordinates are given by in terms of x plus 1 comma y, x minus 1 comma y, x comma y plus 1 is another coordinate, another x comma y minus 1 is another coordinate. So the relationship is here we find in between horizontal and vertical neighbors of the pixels. So how can we understand this? We'll see one by another in coming slides also. So we can understand that is this set of pixels called 4 neighbors of a pixel P is denoted by n suffix 4 of P. Okay. So that means what you understand that you are going to understand n suffix 4 of P. Each pixel is a unit distance from x comma y, and some of the neighbors of the pixel here pixel P is lie outside the digital image if x comma y is on the border of an image, So we can understand this. Simple description is here. What it says is, it shows the relationships of the pixels. So how can we define this? Let you see here. Let you see this. Here, n suffix of d of p. N is what do you mean? Neighbor of pixel represent in terms of the diagonal neighbors of a pixel p. Okay. So how can I say that is here by considering one of the best example is 4 diagonal neighbors of a pixel p have coordinates and are denoted as n suffix of here. Simply we'll write n suffix of d of p. N suffix of d of p. Okay. So these points together with the 4 neighbors are called 8 neighbors of p denoted by ng of p. G means here. What do you mean to understand G? It is nothing but 8. Okay. So not G. Okay. So it is nothing but 8. N suffix 8 of P. What do you mean this to understand is, instead of previously, here also it's not G. It is 8. So what do you mean to understand here is, to change these diagonals of neighbors to 8 of P. So how can we change the 4 to 8? How can we change? Because we are going to be change here the points of nd of P to n suffix of 8 of P all fall outside the image. If x comma y is on the border of an image. To get this clarity, let me to explain with one empty slide. Okay, so by taking an image, of course you are taking an image, obviously. Okay, you are taking this image. You are taking this image is in terms of coordinates only. Obviously, we defined that neighbors of pixels is nothing but we defined that in terms of coordinates. What are the coordinates we are taking? Because you are taking images here, a two-dimensional image. This is image. This is, let us assume this is an image. Okay, so this image now we are going to keeping into in terms of two-dimensional. Two-dimensional means x comma y coordinates image only. Okay, so when we are going to have this image, okay, now we are going to be see the some relationship, some relations, some basic relation, basic relationship, basic relation. Basic relationship of a pixels. So how can we define this? In the sense, you are taking here x comma y. If you suppose you are taking this x and y, is we can write simply x comma y is 1. Okay, so that means if you are taking this right side, okay, and top is plus 1. If you are taking opposite is minus 1. To whom this minus 1? If you consider this in terms of x minus. If this one is opposite to y. So what is the y in terms of opposite? It is nothing but negative. Okay, negative to y. This is which we are consider is x. X is this is y. Okay, this is x. Okay, this x is nothing but this direction. Okay, my consider is minus. This direction means positive. Positive x. That is plus. That is plus here, plus. So according to this, I am preparing here this one. What is this? Previous one is, this one is 4, which we are going to consider 4. What is that? Is coordinates based. Okay. So what is this 4? 4 is the 4 sides of the an image. 4 sides of it. So first positive means x plus 1 comma y. The second one is x minus y, x minus 1 of y, x comma y plus 1. So x comma y minus 1. See, you can understand here this. So you are going to be consider x comma y is 1. Another one is x comma. If you are going to be consider one side of this x, okay, this x. So x plus 1, x comma, sorry, x comma. Okay, when we consider with y plus 1 is 1. Another one is x, comma. If you consider y minus 1 is another side. Okay, next, when you consider the y, comma, x minus 1. So like this, see, these are the changes depends upon the size which you are keeping the relationship in between pixels from x to y relationship from positive to negative to positive, like that. Okay, so you see here, like that only we are written here, like that only we are written here. So here I am returning is sometimes what we call x minus 1 comma y. Okay, so sometimes x plus 1 comma y. Okay, sometimes x comma y minus 1. So this all helps us to define your image relationship towards to negative direction, positive direction of particular coordinates. Okay, so plus minus 1 is coming because of y opposite changes with the x coordinates. Similarly, like that. Similarly, we are going to have that changes of x plus 1 with y. So positive x to varying this one step to vary towards to y in x positive direction. So like that we can define. This is what I am defined here is 4. If you wanted to define the instead of 4 diagonal neighbors of the pixels to 8, that means this is called n suffix 4 of p. If suppose instead of n suffix 4 of p, if you want to define n suffix of 8 of p, okay, so there we are going to be extended your coordinates. So that means your number of coordinates are going to be vary here. See here, what is this? See here, if you see this 8 neighbors. What do you mean 8 neighbors? We are varying these relationships in terms of diagonally is from 4 neighbors to 8 neighbors. 4 neighbors to 8 neighbors. You see here 1, 2, 3, 4. But whereas if you go to here, it may be extended. It may be extended. You see. What do you mean to that? This is the additional of the 4 neighbors. 4 neighbors. That means twice. Each way is twice. See, it changes like that. Okay. So such a relationships are finding only depends on the border of the image. That's what I am showing here. This is border. This border only we are finding the relationships. Okay. So coming to the here. So of course, so far we have gone through the neighbors of the pixels to understand the relationship between the pixels. Okay. But whereas here, what we want to understand here, these neighbors of the pixels also be considered in terms of adjacency. So what do you mean to understand here? Let me consider 3 types of adjacency. Number 1 is a fourth adjacency. Number 2, eighth adjacency. Number 3rd, that is C type. So third one is M adjacency. M for mixed adjacency. Next D, that is 4th one, is 2 pixels. That means P and Q coordinates with values from particular value of the image, or M adjacency. How we may define that one is number 1, which P and Q with respect to Q is in P4 of P. Sorry, n suffix of 4 of p is. Now this same thing we'll write in terms of n suffix d of p. What do you mean d here? Here is the set of diagonal of neighbors of the pixels are vary as set whose values are from the your valued image. So this we are going to be see here. This we are going to be see here in detail information. You can able to see here in detail. Okay. Sorry. So in detail, what we wanted to see here by taking one what is that? By taking one of the connected, that means 2 pixels p comma q relations are said to be connected into one space of the pixels if there exists path between them consisting entirely of the pixel space. Let us see, this is one of the pixels. Okay. So we are taking any pixel p in that spaced number of the pixels. That is here. I am keeping like a matrix. Okay. Or I am keeping one spaced. Okay. One spaced. Right. So that are connected to it in the S is called as a connected component of a S. Okay. So how can we say here? You see, you take here. I am arranging the number of pixels into in 3 categories. Number 1, A is nothing but arrangement of the pixels is here. This is A part. Next, number 2, pixels that are 8 adjacency. We want to understand 8 adjacency. That is B part. Okay, we'll go in detail to understand about each one. Don't worry. But point is here, I'm going to be give the more clearance about the adjacency, M adjacency, mixed adjacency, or 4 adjacency, or 8 adjacency. How that changes here. Okay, that diagonal neighbors of the pixels are changing here in terms of adjacency also. So let me see that. What is the C part? C part is the M adjacency. Okay, so that differences we can understand here. You see, what we want to understand here is, if you are going to be see the pixels that are 8 adjacency means, we are going to be see here 8 adjacencies. See, 1, 2, how many? You may be knowing that the pixels which we are arranging here is, okay, how many number of pixels are there here in the first arrangements of the number of pixels are in terms of rows and columns only. We can understand in terms of rows and, so 3 rows and 3 columns. So m by n. M by m equal to 3, n equal to n. How many total number of pixels will come here? 9. Okay. Out of 9, what we want to understand here is the adjacency of the number of pixels are here, which we want to concentrate 8 adjacency. Okay, so 8 adjacency, how we maybe changes that. That means the relations of pixel from 1 to this and this and this. How many it may be changed? 1, 2, 3. What do you mean to understand here? You are going to understand these changes in terms of shortest path. So how can you understood this is in terms of shortest path is 1, 2, 3. Or else if I go like this. Okay. So 2 to the power of 3. What do you mean 2 to the power of 3? 8. So here what we want to understand is in terms of that pixels which we want to see in terms of adjacent pixels, to have the relationship in between one pixel to other pixels in terms of shortest path to understand. That means the content of the image is right now more visibility or less visibility. That is a capital V, visibility. Okay, so more visibility or less visibility, how can we find? We understood that 0 is nothing but one type of visibility. So if we take the black and white, okay, so let us, we understood 1 4 is one color, another 0 is another color, black and white. Black means 0, 1 means white. Let us be understood like that, or vice versa. Okay, so that means the relationship in between one to another, you are going to find out in terms of visibility, one pixel to another pixel. You are going to be see that in shortest path. So to find that relationship in terms of shortest path, we are going to be use that 8 adjacency process, or else we are going to see the M adjacency. What do you mean M adjacency? Mixed adjacency. What does it mean? M adjacency means mixed adjacency. So we are going to be keep here mixed adjacency. So we are going to be keep like this. Okay, so that path only we are connecting here once. You see, mixing together. So I'm going to have that meaning of connected components in a space. Yes. You see that now the pixels in the space of particular arrangement of the pixels on this in this one particular space, we may find certain relationships. So this is what we want to understand, the difference between pure neighbor of a pixels relationship or purely that diagonals of the neighbor pixels compared to now that in terms of diagonal pixels variation is right now adjacency point of view. Adjacency of the pixels point of view we understand. That we'll go to how this image which we are wanted to understood here. Okay, that pixel is the smallest element of an image, that each pixel corresponding to the value, having the value, one value. Okay, so if suppose for example, if you are going to take 8-bit grayscale image, what do you mean 8-bit grayscale means? It is not purely, it is not a color image, no doubt. Okay, so being it is 8-bit grayscale image, we are going to have that. Okay, so how many number of pixels will come for this image? Because of it is 8-bit, so we may be going to change that 8-bit of the gray level of in terms of number of pixels, that is 2 power of 8. How many will come? Will come minimum of minimum 256 pixels. So we consider that pixels relationship in between 0 to 255. Start from 0 and ended with the 255. So that relationship we are finding in terms of in terms of any point corresponding to the intensity of the light photons sticking at that point. So intensity is playing vital role here to say whether the pixels are has a relationship or not. So intensity of an image varies, the pixels of the relations also varies. That means in that particular path of an image in terms of adjacency or diagonal lines of a pixel like that. Okay. So what we want to understand from here, from this slide is, yes, we understood that by taking an image which is a grayscale image, keeping that grayscale image of the pixels values, each pixel store a value proportional to the light intensity at the particular location. So that is what only. If we take the image, so you are going to find particular image at the middle of the image, a particular image pixel value is varying here in terms of 0, 0, 1. So what do you mean to understand 0 here? So we are understanding 0 only in terms of grayscale is, you may be seeing that grayscale means black and white image. That image values you may see, observe that pixel values is a 0 or 1. Visibility or non-visibility. So that we are going to find at a particular location. So location is important here. You see here, let me to provide you the clarity about that location of an image. Okay. So we are taking here, of course, here I am taking here grayscale image. This is grayscale. Okay. So being it is a grayscale image, right? Being it is a grayscale image. So here I am keeping here how many rows and how many columns? 1, 2, 3, 4 rows. Okay. How many columns? 1, 2, 3, 4 columns. So 4 by 4 matrix. What is this matrix? Simply I can say that grayscale image. So my intensity, my focus is on here towards to define your image pixels of relation which varies in terms of intensity of the image. Okay, depends upon. See that a sensor I am keeping here. What do you mean sensor? Sensor mathematic camera. So if we by taking the camera based image we are studying here. So okay, so that focus is here sticking completely intensity value changes. See, I am taking as a sensor. Okay, that sensor sense the intensity of a sticking photon values. So here is particular value is captured here, that will be called as 1 pixel. So simply we says that one is how it is captured is by the relationship between 1 pixel with another pixel. So compare both. When what you are comparing here in terms of zeros, 1. So you compare 0 to 1. 1 may be 0, 1 may be 1. So compare both and finding the intensity value. Intensity value is more in the sense 1. Less means 0. So we are finding that grayscale image. Again we are going to define in terms of black and white. Okay. So such a way we are going to find the relationship between the pixels. Of course, you followed me towards to understand that pixel relationship based on the intensity of an image. So coming to the here, I want to provide you some more clarity by doing one simple calculations are here is. So let me to calculate of total number of pixels by taking one of the study, that is here I am defining the image has a two dimensional signal or a matrix. That means two dimensional matrix image I am having. Then that matrix which we maybe says obviously being we called as a matrix, so it has a rows and columns. When it has rows and columns, based on the number of rows and number of columns, we find the total number of the pixels. We find the total number of pixels by multiplying the rows and the columns. So based on that rows and columns, being it is a two-dimensional matrix or two-dimensional signal, it has coordinates of x comma y because it is two-dimensional. It is two-dimensional matrix. So when we are looking at per particular of image, we will calculate that relationship and image compare with the in a color image. So how can we compare that? Obviously, we have to take the one grayscale image. Grayscale I have taken. Okay. So when I am taking grayscale image, what do you mean grayscale image here in terms of pixel relation? Means the value of the pixel at any point denotes the intensity of image at that location. That is to also known as grayscale. I'll repeat. The value of the pixel at any point denotes the intensity of image at that location, and that is also known as grayscale. We will see in more detail about the value of the pixels in the image storage and bits per pixel tutorial, but for now we will just look at the concept of only one pixel value, that we may define pixel value as a 0 or pixel value as a 1. As it is already been defined in the beginning of this discussion here, that each pixel can have only one value and each value denotes the intensity light of your particular point of an image. So with this, we are going to have a simple calculation is here. Let me see here. We will now look at a very unique value 0. The value 0 means absence of light. It means that 0 denotes dark, means black. And it further means that whenever a pixel has a value of 0, it means at that point black color would be formed. Now this image matrix has all filled up with 0. All the pixels have a value of 0. If we were to calculate the number of, that is total number of pixels from this matrix is low. How in the sense? Sorry, it is not low. How we find that value is here. We are going to find it in terms of total number of pixels is equal total number of rows and total number of columns. We are taking is here 3 rows and 3 columns. Example, 3 rows and 3 columns. Then we will find out the total number of pixels is 9. So once we got the clarity about the total number of pixels for finding from the particular image in terms of matrix, so it means that an image would be formed with 9 pixels and that image would have dimension of 3 rows and 3 columns, and most importantly that image would be black. The resulting image that would be made would be something like very clearly saying that in terms of 3 rows. 3 rows, 1, 2, 3. Sorry. So simply saying 3 rows. 1, 2, and 3. Columns also 3. 1, 2, and 3. See here. 1, 2, 3. So 3 rows. So 3. This is matrix. 3 by 3 is equal to total number of pixels. So this is what we want to understand, the calculation which provides only in terms of relationships. For example, let us take one of the transformation between these 5 frames. Number 1, 3D, that is object coordinates in terms of 3D. Number 2, world coordinates in terms of 3D. Camera coordinates in terms of 3D. Image plane coordinates in terms of 2D. And pixel coordinates 2D in terms of intensity. 2D intensity. So what is this? These are also helps towards to understood the relationship between pixels. So once we understood this relationship, for example, let me take one simple example. That's how a 3D image scene is transformed into 2D or vice versa. with image of pixels. Now we will explain this concept mathematically by using the simple figure. You know, the y-axis is this, x-axis is this. Okay. Now the image is in terms of 3D, or the image is in terms of 2D. 2D means you consider only y-axis and the x-axis. But 3D means we extended in another, that is, x and y. This is y, this is z, and this is x. So when we find x comma y comma z of particular coordinates, so relationships of the matrix or relationships of the image, values helps us to say it is 3D image. When you say only in terms of x comma y, relationship of the image is 2D. This is 2D, this is 3D. So okay, this is 3D, 2D, and so what we want to understand here, from these coordinates, here you see the provided image. He is here y, he is here is x, and he is here is here. Another line is dotted line is here is z. So x, y, and z. So with these relations, we can define your 2D to 3D. Let you see that where 3D object and we convert it into 2D image. So f is the focal length of the camera and z distance between the object and the camera. Now there are two different angles formed in this transform, which are represented by Q. So the first angle is here we are finding that tan theta equal to minus y by f. What do you mean minus value means? It is inverted image. So that means where minus denotes the image is inverted. Where minus denotes that image is inverted. The second angle that is formed as a without minus, that is tan theta is equal to y by z. Here there is no inverted image. So that means by the using of that relationship, comparing two equations, we get y equal to minus f of y by z. Okay. So that is a simplification. By simplification only we will get this. So from this equation, you can see that when the rays of the light reflected back after sticking from that object, passed from the camera, an invert image is formed. So we can better understand this. The best example is here, calculating the size of an image formed. Let me take one example. This is example. In this example, what is given, what is the provided information is, suppose an image has been taken of a person 5 m tall. I am reading provided example data and standing at the distance of 50 meters. So from the camera, and we have to tell that what is the size of an image of the person with camera of focal length is 50 mm. Now by taking this data 1, 2 and 3, we will find out the size of the image. We will find out the size of the image. The given data is here. Okay. So with this, how can we find here? Start the solution. Write the given data. What is the data we are given? First of all, what he has to do? Since the focal length is given in terms of millimeter, we have to convert that millimeter into meters, because we have to calculate in the sense unit should be uniform. So the uniform units which we are maintaining here is converting 5 meters to millimeters, that is 5000 millimeters, 50 mm, that millimeter, 50,000 millimeters. So now we got y value, f value and z value. Okay. So once we got this and substitute all the values in provided equation. What is the y? Y is nothing but the value of the you're finding that image. That image. Okay, that image size. Okay, so minus f of y comma y by z, substituting all the values and finding, we got is minus. So that is minus 500. So what do you mean that minus sign indicate that your image is inverted. That's the image located in terms of size inverted. So once you understood this image, immediately we are going to see that image of pixels in terms of bits. That means bits per pixel denotes here. Bits per pixel denotes. This number of bits per pixels helps us to understand different colors of any image is depends on the depth of the color or bits per pixel. Okay. So bits in mathematics, what do you mean to understand that? They will ask a simple information that it's just like a playing with the binary bits. How many numbers can be represented by one bit is here, either 0 or 1. How many 2 bits combination can be made from the 0 and 1 is 0, 0. So you know 2 power of 2 because 2 is nothing but here. How many combination? 2. 2 bits only we can donate it, either 0 or 1. So 2. We'll keep 2 power 2. How many combination will come? 4. So what are the 4 combinations are here? This 4. 0, 0, 0, 1, 1, 0 and 1, 1. So this is the my complete explanation about some basic relationship of a pixel. I hope you understood from first slide to up to end of the slide. I'm very thankful for your patient reason. Really, we are going to see the remaining things in coming class. Okay, thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.